Hey guys, the last time in 7.5 we talked about the unit circle and its meaning, right? And there we also talk about the even odd properties. So we only have two even functions among the six trig functions. They are cosine and secant, right? And then the other four functions like tangent, cotangent, cosecant, and sine, they are odd functions, right? So what is special about like even and odd functions, right? So for example, if I give you something like, I don't know, like secant of negative 20 degrees, because secant is an even function, right? So the negative in here will be dropped, and then we're gonna have it equal to secant of 20 degrees, like positive 20 degrees, okay? And then in another scenario, if we have like an odd function, for example, if I give you guys something like, I don't know, like sine of negative 20 degrees, and again, since sine here is an odd function, the negative will be brought outside, okay? It's not going to be canceled, just like the case of even functions. For odd functions, the negative must be brought outside, okay? And then the angle in here will become positive, okay? So as you notice, like from the beginning, we have like a negative angle, right? And then later on, we're gonna turn them into positive angles. Sometimes for even function, the negative will be dropped by itself, so then we don't have to do anything because it's even, right? But then for odd functions, you have to do one extra thing. You have to bring the negative outside, okay? It's not going to be dropped by itself, okay? It's not going to go to cancel by itself, okay? And in 7.5, I also promise you guys that we're going to talk about the periods of each of the six trig functions, right? So today, let me show you guys at least the periods of sine cosine functions, okay? So let's talk about 7.6, the graphs of sine cosine functions. So just a quick heads up in here before we get into like further details of the graphs. This table in here is a table of transformation of function graphs, right? Each of them have like the meaning in here. I'm not gonna like make up like 8 examples for each of the cases in here, but just keep in mind that this table is very important in the sense that you need it for the test. You need to understand like each of the transformation between like the new function and the original function, okay? And I will tell you guys what original functions we have later on. We'll get to into the examples, but for now, if you want, you can take a screenshot of this table and just keep it in front of you, okay? Just, you know, like as handy, okay? And then let me talk over like the first page in here. So the graphs of sine cosine functions again, right? So to graph them, first of all, we need some points, right, in order to plot them and then connect them, right? So to my experience, we're gonna use this set of 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, okay? And if you see them like familiar, these are actually like the 4 quadrantal angles. And I know that like there are 5 of them, right? But then the 0 and the 2 pi are actually the same thing, right? Because like 0 and 360 degrees, they end up at the same spot, right? So these are the 4 quadrantal angle. Quad angle. For shortcut, I'm just gonna put like quad for quadrantal. Okay, and if you notice, I usually told you guys to like draw a unit circle for this one. So this is my x and y axis, and in there I'm gonna have like a unit circle. And then for x is for my cosine, and for y it is for my psi value. Okay, in here this is like the 0 degree, right? And if you want to like label the point in here, this is like 1 and 0, right? And then the 1 in here would represent the cosine value, and the 0 would represent the psi value of the angle 0 degrees or 2 pi or 360 degrees, okay? And the same thing, you can find a point in here that corresponding to the angle of 90 degrees, the point here that is corresponding to the angle of 180, and then lastly we have 270, okay? So we're talking about sine, right? And this is like the y part, right? Like among the coordinate. And later on, if you notice, we're going to use the same set of the 4 quadrantal angles also, but for cosine, right? And because we talk about cosine here, for the second table, we're going to use the x part. Okay, so let's fill in the first table. At the angle of 0 for the y part, we have 0, right? So then this is 0, okay? Let me just fill out everything in here, like all the 4 points in here before we move on further, right? So this is like 0 and 1, and in here I'm gonna get like -1 and 0, And lastly, from below, I'm gonna get 0 and -1. Okay. And again, if you don't understand like how we have these points, please let me know as soon as you can before we have quiz 2, like on next Friday. Okay. So watch out for this one. Okay. So we talking about only the y part, right? So we have like 0 in here and then 1 and then back to 0 and then -1 because it's like the bottom point and then back to 0 again. Okay. And with like the same manner, but then we talk about the x part in here, we're gonna do 1 and then 0 and then -1 and then 0 and back to 1. Okay, so these are all based on like the 4 quadrantal angles and its xy coordinate. Okay, so let's plot them out, right? The first one, we have the first pair 0 and 0, which is like right here, right? The second pair we have at pi over 2 we have 1, which is up here, and at pi we have 0 down here, and then 3 pi over 2 I have -1, and for 2 pi up here, right? So for this one you have like a lot of ways to like connect them, right? You can go like wavy, you can like go straight, but then I told you like a heads up is that sine and cosine functions, they must be like wavy. Okay, they must look like, you know, like an ocean wave, or you know, like a water wave, as you can see in like the sea. So some people, they might be thinking about like having it done like this, like just like straight lines connecting to each other, but this is wrong. Okay, so please don't do that. Okay, the sine function will look like this, curvy. Okay, and I know I make like a bad picture, it's not gonna be super flat in there. Let me see if I can do a better job at this one. I'm really bad at drawing, so I'm trying to make like the U shape in here, but I'm not sure if I can get that. But again, like the pictures in here is they are available in a textbook, and if you want to look it up, you can just simply Google the graph of sine function. Okay, and then from there you can see like a better picture of sine. Okay, and then does it stop in there? I mean, no, right? Just because you have like, you know, like 360 in a circle, it doesn't mean that it's the ending point of the circle, right? So if you want to go beyond like 360, if you want to add like 90 on top of like 360, let me see what it is. So we get 360 plus 90, that is 450, right? And then that will be like up here, up top, so that if you want, you can like continue drawing them like in this same manner, right? And then you can extend it to both sides, right? And it's gonna look like wavy right there, right? So first of all, like one of the feature of sine function, again, it looks wavy, just like, you know, like waves, and it passing through the origin, right? Like this is one of the special feature about sine, the original sine function. It has to pass through the origin. Okay, in the next second you will see that the cosine function, it doesn't pass through the origin. That's why it makes a difference between the two wavy functions that we have in this page. But this is like where we have the sine function. And let me take out some part in here so then I can fill out the information that you want to see in here. So as for the maximum, we're gonna have like 1 point. This one is a maximum, right? Because it's like the highest point there. So we have 1 point as pi over 2 and 1. And notice that we're gonna have like a lot of maximum points, right? Like, but in here, to keep it simple, let's consider only the first cycle, right? And what do I mean by the first cycle? I mean, let's consider from like 0 to 2 pi. That means we're not gonna have this part. It's just gonna be between 0 and 2 pi, okay? And from there, as you can see, we only have 1 max and 1 min, right? The max in here would be at the x value of pi over 2, and its value is 1. The minimum in here is at x equal to 3 pi over 2, and its value is -1, okay? And again, we only have like 1 point, right? But if you look at this table in here, we have like 5 points, right? So this is like 1, this is another 1, so we have like 3 more points, right? Like, what are those? I'm gonna call them the midline points, okay? What do I mean by the midlines in here? So if you just imagine, like, if there's something in between the max and the min in here, it would be this dash line in pink. Okay, so let me just put like a dash line in here to separate like everything out like halfway. Okay, like I want to cut out everything in halves. Okay, that's why I'm gonna use this pink dash line to cut out the whole graph, like, you know, like to top part and bottom part. And then there, if you take a look at the 4 quadrantal angles, you will see that this point here, and that point there, they are lying on the dash line, or they are lying on the midline, right? That's why on the midline we're gonna have 3 points, right? The first one is 0, 0, and then the middle one is like pi and 0, and the last one is like coming back to the circle, so it's 2 pi and 0. Okay. So for cosine, it's pretty much the same thing. We're gonna have wavy again, but then since, okay, let me use it in red. Okay, that's weird. Okay, so we're gonna have the point of 0, 1, which is right here, and then we keep like plotting on the points in here, and we're gonna have some sort of like a V form, right? But make sure you don't draw the V form, okay? Because it's supposed to look wavy, okay? And what does it mean by wavy? It's gonna look like this. And again, I'm trying my best to draw like a nice curve, but you know, like I'm not like an artist, so I cannot make it perfect. And if you want, you can look it up online just by Google like the graph of cosine, right? And if you want, you can take a look in the ebook. It has like a lot of pictures for cosine and sine, and then you can like check it out, okay? And for cosine here, we only talk about like the 5 points in here, right? But there could be more points than that, right? That's why if you want to extend the graph in here, you can also do that by keep drawing in this manner. And then also on the other side, you will have the same thing, right? And it keeps going on and on and on and on, right? But then take a look that it misses the origin, right? Like the origin is right here, and the origin is not like a part of the function, right? Like as you can see, the origin in here is not on the red curve of cosine here. So that's why I told you guys like the cosine here, it misses the origin, while the cosine here, it passes through the origin, okay? So keep in mind that like that's a big difference between the two wavy functions that we have in this page, okay? And again, to keep it simple, let's talk about the first cycle in here between 0 and 2 pi. So let me take out this part in here and that part in there, okay? So if you take a look at like among like the 5 points in here, we're gonna have one maximum, one minimum, and again the midline with 3 points, right? And let me draw the midline here just in case you guys cannot like see it, or like just to confirm if this is the same thing that you guys have for the midline, okay? And if I confuse you guys with the idea about the midline, please let me know, okay? And in here, I think I make a mistake. Okay, let me fix this one really quick. This one, okay, the maximum in here, it should be 0 and 1, okay? So here, let me kind of, I don't know how to erase this one from the PDF, but please ignore like all these points here. I think it's just my copy and paste, like, you know, like from Sine. So let me put it in green so that it catches your attention. So the maximum in here, we're gonna have 2 maximum points in here, okay? The first one is 0 and 1, and the other one is 2 pi and 1, okay? For the minimum, we're gonna have just one of them, which is at pi and -1, okay? And then for the midpoint, for the midlines, we're gonna have 2 points, okay? Not 3, but 2. We're gonna have pi over 2. Okay, let me make an error in here because pi over 2 is like, you know, like big. And 0, and then the other one is 3 pi over 2 and 0, okay? So, excuse me, answer for this one. I'm glad I catch this one like right away before I make it like, you know, like worse. Okay, so note that sine and cosine are periodic, right? Like if you can see, I told you guys, if you want, you can extend them, right? So let me put it in blue. So say for this one, if you want, you can keep continuing like this pattern, and then same goes for the other side, and then same thing with this one, right? And then same goes for the other side. Like everything is repeat, right? Like you can see this pattern, pink in here, it repeats right here. Let me put it in, I don't know, like brown. These are the same thing, right? And if you keep like drawing the function, you will see them repeat and repeat and keep repeating, okay? And as you can see for the psi function, here the first cycle is this one, right, from here to here, and then the second cycle after the first cycle is gonna be this part from here to here, and then the next cycle is gonna be from this part from here to here. So they all repeated, right? Like from here to here, and then it repeat again, and then, you know, like it keeps going on until you want to stop it, until you're like running out of paper, okay? So that's about like the periodic and what it means. If you notice, it's at the period of 2 pi. Why do I say so? Because from 0, it takes 2 pi to get it repeat to itself, right? So this point is not, this point here is not 0. I mean, it's not like the same position. It's not, it doesn't have like the same height, right? So it takes like this whole gap from here to here to make the cycle repeat itself. And the gap from here to here, it is 2 pi, right? And same thing in here, the gap from here to here to make it repeat itself for the next cycle is 2 pi, right? So that's why the period for sine and cosine, it is 2 pi. Okay? And the last piece of information that I didn't say in this page, here, let me take out some like work in here so then, you know, it will be like cleaner for us to focus at. Okay, this takes some time. Okay, there we go. That's cleaner. Okay, so one big piece that we have to pay attention in here is about the domain range, right? It takes forever for this thing. Okay, the domain range. The only thing that I forgot to mention in this page is the domain range, right? So let me put back the graph really quick in here. So this is like this, right? And there, and then this one is like this. Okay, like good enough, right? Okay, the domain of psi function, it takes all number, right? Like in here it passes like all the x value, right? There's nothing that makes psi undefined. Same goes for cosine. There's nothing that makes cosine undefined, right? So that's why the domain for cosine and psi is always just all real numbers, okay? Because, you know, like sine and cosine value function, they can take any value. If you throw in like a 0 in there, that works too. If you throw a positive number in sine or cosine, that works too. If you throw like a positive number in there, that also works for cosine and sine, right? So it takes all real numbers for the domain. For the range in here, if you notice, the maximum value in here it can go up to is 1, right? And the lowest value it can go to is -1, right? So it is like is moving between -1 and 1, okay? Like in English, we can say that any real number between -1 and 1 inclusively. So what does it mean by all real numbers between -1 and 1, right? So it means that you can have, I don't know, like 0.9 or like -0.2, 0, and also including there. But you cannot have 2, right? Because 2 is not between -1 and 1, right? You cannot have -5 because -5 is like way out of the range of -1 and 1, okay? So everything for the range of sine and cosine, they must be in between -1 and 1 inclusively, okay? So that's some like flavor about the graph of sine and cosine. Let's talk about how we can actually like graph them, right? So to make it easier in here, I'm gonna show you guys like a table just by like using the algebra for it. And the second method to graph this thing is by using the table of transformation of the graph of functions, like what we have on the first page of reviewing. I don't want to use it that much, but then I want you guys to understand the meaning of it, okay? So I'm gonna like tell you, I'm gonna interpret the meaning of each of the like math part in here, but I don't want you guys to like go from there to get the graph, okay? It's gonna be like super complicated. So for my way to do like to draw a graph of psi function, first of all, I want you guys to think this one is like a function, right? So we're gonna have like two numbers. A in here is the number in front of psi, and W, or like omega in here, is a number inside the parentheses, but like in front of x, okay? It has to be like strictly between sine and x, okay? So there are like two numbers in here that I want you guys to like keep in mind, okay? So for sine, please remember that we always going to use the 4 quadrantal angles, but just because it's 4 quadrantal angle, it doesn't mean that you're going to have 4 points, right? We always going to have 5 points because the 0 and the 2 pi, they repeat, okay? So make sure you're going to use a set of 5 points in here. And then you can always like draw out a unit circle to fill out like these number in here. Remember, it's just the y part, right? Like the psi is the y coordinate of the points in there. Okay, and now if you want to get like the new x, then you're gonna use the old x divided by w, okay? And if you want to get the new y, you're gonna use the old y multiply it by a, okay, and then you're gonna get a whole set of new x's, a whole set of new y's in there, and then you put the x and y together, and then you're gonna get the point. Okay, simple enough, right? It's like a lot to memorize, I know, but it's really simple compared to the second method. If you have to use a transformation, it's gonna be harder. Okay, so for my example in here, my a in here is -2 because I have like -2 standing in front of psi, right? And my omega or w in here is 1 because I have no number in front of my x. Okay, so it's invisible. You can consider it as a 1, but make sure you don't treat it as a 0, okay? Because 0 in here, it doesn't like, you know, like valid, because if it were to be like a 0 standing in front of x, if you have 0 times x, it's actually 0, right? Like 0 times x cannot be x, right? So be careful with like the number in front of x in here. Okay, so my rules in here is that okay, first of all, let me take out these information. So I told you guys that there will be like a column for the new x, and there will be another column for the new y, right? And then at the end we're gonna put them together as a point, like new points. Okay, since my w in here, my omega in here is 1, right? So if you notice, if I plug 1 into this information in here, I'm gonna get my new x equals to the x, like the old x divided by 1, which equals to the old x itself, right? So that means that I don't have any new x, right? Because the new x is just the same thing as the old x. Okay, so then if you read my notes in here, like I make a quick note in here. So if there's no w, there's no new x. Okay, in this case, it's no, what do I mean by no w? I mean like in the case of w equals to 1, if you want to consider it that way, or if you want to see it as like there's no like number in front of x, like visibly, then there's no w, right? Then there's no new x. Okay, and then if there's no a, then there's no new y. Okay, it's like a mix and match of like a and w. Okay, if you have like if you have w and you have a, then you're gonna have new x, new y. If you don't have like one of them, then you're not gonna have like either new x or new y. Okay, like it will make more sense if you have like the examples down. Like if you do it in the homework, it will make more sense, I promise. Okay, so for my example, my w is 1. That's why my new x and my old x are the same thing, right? So as the point part, I'm gonna rewrite all the x's because I know that they are the same thing. So I have like 0 in here, and then pi over 2, and then pi, and then 3 pi over 2, and lastly I have 2 pi. Okay, so my mission now is to find my new y, right? And I give you guys a formula. The new y equals to the old y times a, right? And my a in here is -2. That's why I'm gonna do y times -2. And what does it mean? It means that I'm gonna take each of these value and times it by -2. Simple enough, right? So first thing first, 0 times -2, I'm gonna get a 0. 1 times -2, I'm gonna get a -2. 0 times -2, I'm gonna get 0, and like similar logic, I'm gonna get 2 in here and 0 in here, right? And now that I have the new y's, I'm gonna fill them in here, and make sure you put them in like parentheses as for, you know, like point simple. Also, I'm gonna take out some partial credits from your work. Okay, so watch out for that. Okay, now that we have the points in there, so let's plot them out, right? So first point, we have 0, 0. Second point, pi over 2 and -2. So pi over 2 is like in the middle, and -2 is right here. Pi, we have 0, and then 3 pi over 2, I have 2 up there, so this is that. And then 2 pi, I have 0, right? And again, I told you guys, sine and cosine would look wavy, right? So let me try my best to make them look as wavy as I can. There we go, that's good. Okay, in this problem, because I'm asking you to draw it in the first cycle, so you can stop in there, right? But I don't know, like if you guys want to be creative and you guys want to like play with it, you guys can also extend it in like this fashion, right? To both sides. Like I don't care, but then make sure you read the question carefully in the test, okay? To not waste your time and waste your work, right? So in this one, I'm gonna take out the blue mark because it's only about like the first cycle, right? And then let me put a green star on your part. And just a heads up in here, you do have A in here, and you do have W in here, right? That's why you can have new X and new Y, okay? And another heads up is that like in the test, I'm gonna give you a table like this, but then everything will be blank. I'm not gonna give you guys the set of points. I'm not gonna give you guys the set of values. I'm not gonna even like give you guys any of these information, okay? Like you have to know how to use this table, and you have to know the position of them, okay? But lucky you, because this is like online course, so make sure you have this table down somewhere to get ready for quiz 2 and test, okay? So then you will know the position of like the values, and then you know like what category goes where, okay? So that's something to keep in mind, okay? And now let's move on to the next page. Cosine function. So similar to what we had before for sine function, for cosine function, we're gonna have an A and we're gonna have a W, right? And in here, we're gonna have the same formula. The new x in here is x divided by W, and the new y in here is y times A. And if you ask me like how I came up with this formula in here, well, it's pretty simple actually. For the y part, you always keep it, right? So in here, if you notice, between A and cosine, we have multiplication. That's why we have multiplication in here. But for the x part though, it's gonna be different. If you have multiplication inside, you're gonna have to do division, okay? And if I were to give you something like, I don't know, x divided by W, then in here, the column, it would be x times W, okay? But I promise you guys not gonna have to come up with those formula in there. Like I came up with these formula to help you guys like, you know, like graph things better, and then you know like it's a quicker way to graph it. So I'm not gonna, you know, like throw like curveballs at you guys this hard, okay? So that's just something to, you know, like to know, like fun facts, like how I came up with the formulas, okay? All right, same deal, same game, right? We're gonna have like the 4 quadrantal points in here, but then if you notice the values in here, they change, right? Because the cosine here, they're all about the x part, okay? And then the y part are for side values, okay? So make sure you pay attention to them. So if you notice here, let me like highlight that. This column is different from this column, right? And why is that so? Because this is about sine and this is about cosine, okay? So make sure you pay attention to that part, okay? And again, cosine is for x, sides are for y, okay? Make sure you don't mix them up, okay? And now let's continue my work in there. So again, like the notes, they are like the same thing from before. I just copy and paste this one, so if you want, you can like rewrite it or like reread it. About my part, again, like we're gonna have this first circle drawn in there. So what should we do, right? In here, let me give you guys A and W. My A in here is obviously -2 because it's the only number that's standing in front of cosine. And for some of you guys, like some common mistake that I had from last semester and also last semester from like, you know, like my students, I want to share with you guys is that make sure you take everything that is in front of cosine, right? Like a lot of people, they just write this one as 2 and that throws everything away because the amplitude in here is not 2. The amplitude in here is -2, okay? So watch out, be careful with the signs, okay? And by the way, I didn't tell you this one, but then there's a name for A and there's a name for W, okay? A in here, we call it A because it's shortcut for amplitude, okay? Like the word amplitude. I'm gonna talk about this one in like, you know, like in the 5th objective or like in the 4th objective later. But yeah, just a heads up, like A is for amplitude and omega, this is like omega, or if you want to call it like W, this is Greek letter, okay? It stands for like, you know, like the inside number, like the scalar number, okay? But I'm not gonna test you guys on like, you know, like the terms in there because it's hard already for the concept. So don't worry too much if you don't like remember the terms for them. At least for this moment, just remember that there's an A and there's a W, okay? Don't get mixed up with them. A has to be the front number and W has to be like the back number, okay? So just like before, my A is -2 and my W in here you can say is there's no W and hence there's no new X, or you can say that, well, my W is 1, right? So when I plug it to the formula right here, my new X equals to the old X divided by 1. So that means that my new X is actually the same thing as my old X, okay? So with that logic, with that saying, I'm gonna set up my points first in there by open parentheses. And because my new X are the same thing as my old X, I'm gonna rewrite all the X parts in here first before I get them like, you know, mixed up with like the Y part. Okay? And then for my new y, well, I have a formula, right? I have y, the old y's times a, right? And then in here, my a is -2. That's why I came up with the formula. I'm gonna grab each of the 5 values in here from the old y, and then I multiply them by -2. Okay? So first thing first in here, -1 times 2, I'm gonna get -2. This is 0, 2, 0, and back to -2. Okay? Now that I get my new y's, I'm gonna fill them in here to complete my points. And last part, I'm gonna plot them so then I can like connect all the points together and have like a perfect graph for the first cycle. Okay? So 0 and 2 point and -2 is like right there, and then pi over 2 and 0 right here. Pi is like up here, and then there, and then there. If you wonder why I do it so fast, because I know the pattern of it already. So that's why, you know, like, if like the numbers make sense with like the pattern, you know that it's right? If not, you know that your algebra must have gone wrong. So it should be like a good time to double check your like numbers, right? So I told you guys it's gonna be wavy, and I'm trying to make it as wavy as I can. So make sure you don't give me like straight lines, okay, in the assessment, because it's like weird to look at for sine cosine. It's gonna look wavy. And then for your part, you're gonna have like the same problem. And in here again, you're gonna have a and you're gonna have w. That's why you're gonna have new x and you're gonna have new y. Okay? So this is your part. And then let's talk about the third objective. Determine the amplitude and period of sinusoidal functions. I know this one is like hard, you know, like English, but sinusoidal is just like a shortcut for sine cosine function. Okay, so we decided to call sinusoidal for both cosine and sine functions, and that's all. Okay, so if you notice, like here, know that the graphs of functions of f, the form, know that the graph of functions of the form. Okay, this is my typo. It's supposed to be the word of the form y equals to this, or like cosine there, are referred. Okay, this is like typo again. This is meant to be referred, sorry for that, to as sinusoidal. Okay, so again, sinusoidal, it's just meant for the graph of sine cosine. Okay, and if you remember the graphs that we originally have from page from page 2, they are like these, right? And I told you guys like the big difference between cosine and sine is that whatever function that passes through the origin, that is sine function, and the other one, it must be cosine function. Okay, so here, let me use like the calico that they already had in there. So I'm gonna use blue because it's right here already and it passes through the origin. So the blue function, this one in here, is actually has another name. It is y equal to psi of x. And some of you guys might questioning like, well, is this one and this one the same thing? And I'm gonna tell you guys, yes. If you guys remember, like the cat, the complementary angle theorem, sine cosine, because they are co-function of each other. So like as long as the angle make up to like, you know, like 9 degrees, then they have like matching with each other. That's why I have like a statement in here, and I refer it to the complementary angle theorem, or CAT, if you want to call it in shortcut. Okay. And next up, like I promised before, A is for amplitude. And if you guys don't remember what amplitude is, or like if that's like a weird word for you, amplitude is the distance from the maximum to the minimum. Okay, I mean from the maximum or the minimum to the midline. Okay, so what does it mean? Say if we talking about like the psi function in here, which is in blue, right? So we have like a max in here, we have a min in here, and again we have like 3 midpoints, right? So what is the distance from the max to the midline? Okay, and let me like draw the midline again before like anyone get confused like what is the midline. So this is the midline, right? Like here, let me make an arrow and then midline. Okay, and this is my max, this is my min, and then these 3 points in here are my 3 midline points, right? So as you can see, let me put it in, I don't know, green. Okay, the distance from the max to the midline, and here's 1, right? Like 1 to 0, this is 1, right? Or if you don't refer it from the max you can do it from the min. So the distance from the min to the midline here is from -1 to 0, and that's also 1, right? So amplitude here is 1, technically, right? So you can do it either way, okay? Either max or min, okay? Like either max to midline or min to midline, okay? That's a definition of amplitude. And if you guys are confused for the symbol of, like absolute value in here, notice that from the max in here we have like a +1, right? But from like the min toward the midline, we have like -1 toward 0, right? And if you take the absolute value of both of them, you're gonna have 1 in either case, right? Like the absolute value of -1 is 1. That's why they give you the same answer, even though they have like different lookings, right? And just remember one thing, amplitude is the distance, right? So amplitude in here is the distance. Here, let me actually highlight it down so that everyone can like pay attention to this. Because amplitude is a distance, it's always positive, okay? We cannot have negative amplitude. Just keep in mind that. A could be negative, but amplitude, it must be negative. I mean, it must be positive. So let me put it in down here really quick. So amplitude must always be positive. But A, it could be positive or negative, okay? Amplitude in here is a distance, that's why it's always positive. But A in here is just like an algebra number, okay? So if you remember from before, from my example, my A is negative, right? So that's why I keep telling you guys, A in here is not like, like it stands for amplitude, but it's more like an algebraic value. That's why A can be positive or it can be like negative depending on the function that you have, okay? It's just telling you the direction of the function, but that's all about it, okay? So keep in mind about that. And let me take these out really quick. All right, and then let's see, what do we have in here? Next up we have, oh yeah, so a shortcut in here is that we always have like this number, right? And then okay, if you look back at this example in here, I'm gonna tell you guys that okay, let me put it in green again. For my part, for my example, my A in here is -2, but my amplitude is 2. Okay, so there's a difference between amplitude and there's a difference between, A. So keep in mind that amplitude, it always has to be positive. But A, it could be positive or negative, depending on the function that you have, okay? And I told you guys from before that the range for sine, cosine, they have to be like ranging between -1 and 1, right? But actually, that's not true. If you talk about just sine, cosine, then that's true, right? But if you have like a number, a front number in front of cosine, sine, in that case, you will have to multiply that number by 1 and -1. That's why we end up having, the amplitude range in here, okay? So for example, here, let me just use my function as an example. So let's say I have this example right here, right? I'm gonna say that its range in here is from -2 to 2. How do I know that? Well, I have the front number in here, right? And I'm gonna do -2 times the range from -1 to 1, right? And this is my range, okay? And I'm gonna distribute like each of them in, so then I end up having -2 to 2, like inclusively. And this is the answer for my range. In the test, I'm gonna ask you guys how to find the remaining range of, like the sine, cosine function, or the other 4 function as well. So keep in mind that you have to like understand this one, okay? Let's see, what do we have in here? So for this example, fortunately we don't have to find the range, but then we have to find the amplitude, right? We have to find the amplitude and the period. So how can we do that? Well, the amplitude in here, we know that A equals to -2, right? So then absolute value of A equals to absolute value of -2, which is 2, okay? And then for the period in here, that's like this information that I haven't told you guys. The period T of the function sine or cosine for like the W has to be like greater than 0. This is like important. Equals to 2 pi divided by W, okay? So this is like a formula that I want you guys to remember. So make sure you have it down somewhere in your paper. So let me use that formula in here again. So here, let me just define W like down here first. So my W is a number in front of X, right? So in this case, I'm gonna have my W equals to 4. And I'm gonna use the formula 2 pi divided by W, which is 4 in here. I simplify it, I get pi over 2. Okay, so the period in here is pi over 2. And the amplitude in here is 2. Okay? Simple, right? But hopefully, like, you will know the formula for each of them, and then you will know which one is A and which one is W. Okay? And then here's your part. Okay, so first of all, make sure you define your A and your W, and after that, for the A part, just take the absolute value of that. For the W part, make sure you use this formula right here to find the period. Okay? Now, fourth objective. Graph sinusoidal functions using the key points. Okay, so if you notice, I always use the set of 5 points, right? Like from before, and I told you guys that those 5 points are actually the 4 quadrant angles, right? Same thing with this one, okay? But this high though, the angles might be like bigger or smaller a little bit. They're not going to be the same as 0, 90, 180, 270, and 360. Okay, they will change according to like the A, the letter A, the number A that you have for the function, for the given function. Okay, so just like before, okay, like this one is a typo, so please ignore this one. Like it's just midline there. Okay, so for side function, we're gonna have like 4 points again, but then since we know that the period is 2 pi already, and then you know, like we find a period by using this formula in here, 2 pi divided by W. So then the beginning point for the first cycle is going to be 0. And the ending point here is going to be 2 pi divided by W, right? And since we have like 5 points, right? So to define like the second point after 0, I'm going to take this and multiply it by a fourth, right? Because we have like 4 gaps in here. 1 gap, 2 gaps, 3 gaps, 4 gaps, right? 5 points, 4 gaps. So again, to get the first point after 0, or like to get the second point, we're gonna multiply this one by 1/4, and the same thing, we're gonna multiply this one by 2/4, or like 1/2 if you want to think about it that way. And lastly, we're gonna do it by 3/4. Okay, so think about it just like, you know, like from 0 to 100, you're gonna have like 4 ways, right? You have like 20%, you have 50%, and you also have like 75%. Okay, so the fourth in here is just like 20%, right? And then the half in here is just like 50%, and then 3/4 in here is just like, you know, like 75%. Or you want to think about it like quarters, you know, like we have like 4 quarters in $1, right? So this is like $0, and this is like $1. So the first gap in here, we're gonna get like 1/4. The second gap in here is like 2/4 if you want to think about it, if you don't refer it to like 1/2. That means that we have like 2 quarters, right? And then lastly, we're gonna have like 3/4 in there. Okay, so that's like my tricks, my way to remember these points. Okay, if you don't want to, think of it like you divide it by 4, and then you just like take each of the gap by like adding it up by 1/4. Okay, let me take all that off. Okay, much cleaner. So that's about the X part, right? So how about the Y part? If you notice, there's a range, right? And I told you guys from before that like instead of having from -1 to 1, now we're gonna have from -A to A, right? -A to A, depending on how the function is. Okay, so what we're gonna do is that, well, the first point for sine, if you notice, like from before, it's gonna go to the maximum, which is like 1. That's why we just have A in here in place of 1. And then we're gonna have like the 3 midline points. They stay the same. You know, the Y parts are always 0 because they, you know, like from the midpoints, right? From the midline. Lastly, for the minimum, we're gonna have -A, right? So instead of having -1 now, because we have the A, we're gonna multiply it by A, and hence it becomes -A instead of -1. Okay, so as a like what is it, a summary, I put down these 5 points in here for you guys. And again, this one is a typo, sorry for that. This one is also a typo, ignore that. Ignore this one also, and ignore this one. It's like whenever you see some words that doesn't make sense, ignore it. I'm sorry. Okay, and then for cosine, we're gonna have the same thing pretty much, right? Let me put it in blue. So this one cosine. The exposition, they are the same thing. So we start with 0 and we end up with 2 pi divided by omega, right? Or 2 pi divided by w. And each of the gap in here, we're gonna multiply them by, you know, like a fourth, 2/4, and then 3/4. Okay? And then as for like the y part, because, you know, for cosine, it doesn't pass through the origin. So we're gonna start with the maximum. Okay, and then we're gonna have like the 2 midlines in there. Here, let me take these out. Okay, so we're gonna end up with the 2 midline points in there, and then we have the minimum and not a maximum in here, just like before. Okay, but in place of like a and negative a, before we had like 1 and negative 1. Okay, that's like just the difference right there. Okay, and then how can I graph it using the 5 key points in here? Well, first of all, I'm gonna define my a. So my a in here is -2, right? That means that my amplitude equals to the absolute value of -2, which is 2, right? And my period, I'm gonna call t for period. Usually in math we try to go with like p for period, right? But then p is already taken for like point. That's why we're gonna use t for period instead of using the letter p. Okay, so keep in mind about that. So t equals to 2 pi divided by omega, or w in here, and in here omega is 4, right? So we're gonna have 2 pi divided by 4, which is pi over 2. Okay, so then what we're gonna do about that? For the first cycle, it's gonna go from 0 and it's gonna end at pi over 2. Okay, so this is my like beginning point, and then pi over 2, this is my like ending point. Okay, and then how can we get all of them together? So first we have 0, 0. That first point, right? Second point, we're gonna have this formula right here, 2 pi over omega, 2 pi over w. We already simplified it, so we're gonna like use a formula of like pi divided by 2. Okay, you know what, let me be more organized about this one so you guys can, you know, like catch up with it easier. So the first one here, 0, 0, we have no formula to plug in, right? And then we all good with that. Second formula, this part we already done it, and it's pi over 2, right? And then we multiply it with a fourth. And then as for the y part is a, and a in here is 2, right? And then third point, we're talking about this point here. It is pi over 2, but then this time we're gonna times a half, right? And then it's a midline, so 0. And then another one, the fourth one, we're talking about this one. We're gonna take pi over 2 times 3/4, and then it's negative a, right? So that means we're gonna get -2. And then the last one, I'm running out of space, but here, let me write up here. We talk about this one in here. 2 pi over omega, or like 2 pi over w, is pi over 2, right? We don't do anything to it, and then because it's a midline point, we're gonna have 0, right? So now let's simplify them to get all the points that we have. First point, we're gonna rewrite it because there's nothing to simplify. Second point, we're gonna multiply them top to top, bottom to bottom, right? So we're gonna get pi over 8, and then 2. Third point, pi over 4, 0. And then next one, we have 3 pi over 8, and then -2. And then lastly, we have pi over 2 and 0. Okay, and again, these points coming from like the 5 formulas in here that you have. Okay, and then let's plot them, right? Like 0, 0 is like this point here, so I'm done with it. Next one, I have pi over 8 and 2, so pi over 8, I'm gonna say it's somewhere in here. Okay, done with it. Pi over 4 and 0 is like in the middle, right between here. Okay, I can do better than that. There, that's my best. Okay, 3 pi over 8 and then -2. Wait, sorry for that. 3 pi over 8 and -2. It should be somewhere right here to me. And lastly, we have pi over 2 and 0. I marked it down ready, so we're all good with that, okay? So now let's connect them. Okay, this is like my best. I think that's like, okay, that doesn't pass through the point I wanted to pass. As you can see, it's really hard to draw like in an iPad. Okay, so this is my point, okay? Like this is my way to draw this function, this psi function in here by using the 5 key points. Okay, and this is for your part. You're gonna have a cosine function, which means you're gonna use the set of 5 points in here. But then again, you're gonna have to find A, and then you have to find the amplitude. You also have to find W in order to find the period, and after that you just go ahead and plug in the 5 points. After you get the 5 points, you plot them and then you connect them to get the graph, and that's it. Okay? Now, last objective of the day, find equation for sinusoidal graph. We can use the idea of amplitude and period to identify a sinusoidal function when its graph is given. Okay, so again, if you don't remember what amplitude is, amplitude in here is the absolute value of A, and period in here is T equals to 2 pi divided by W. Okay, so my tip, recall that a sinusoidal function looks like either a sine function or cosine function, right? And the difference in here between the two is that for sine it's gonna passes the origin, for cosine it's gonna miss the origin. Okay, and then how can we tell A, right? Like how can we get A if we don't get the function but we only get the graph of the function? So notice in here the question will give you the graph and will ask you like, well, what is the function, right? And like let me like highlight this one because definitely I'm gonna put it in the test. So make sure you pay attention to this page in here and make sure you understand what it means for this page in here too. Okay, so we know that we have to find the amplitude and period, right? How can we do that? Well, we have to find A and we have to find W, right? For A, I'm gonna give you a formula in here and I'm expecting you guys to remember this formula that equals to max minus min divided by 2. Okay, so because it's midline, right? Like the amplitude there. So like a short way to remember it, you're gonna do max minus min divided by 2. Okay, and then for omega in here, just like before, we're switching the position of T and omega. It's similar to what we had before. It's gonna be 2 pi divided by T. Okay, so this one in here is 2 pi divided by T, because well this time you have to find T because T is given already, so you have to find omega to get the formula down. Okay, so what do you have to remember from this page? Green in here, you have to remember that this is the formula to get omega and this is the formula to get your amplitude. Okay, so let me put like a string to each of them. Okay, and now let's talk about the example in here. So we have to find the equation of each of the following graphs, right? For my part, I have this equation in here, and the very first thing that I'm gonna do is that I'm gonna draw the midline there in case you guys miss it. Okay, and I'm gonna like mark out like my max and my min in here. So my max in here is -1/2 and my min in here is -3/2, right? And like the formula in here said, my A equals to max, which is -1/2, minus min, which is -3/2, and then divided by 2. If you want, you can put it into the calculator, but in here I'm gonna do it mentally really quick. So in here I'm gonna get 3 minus 1 equals to like 2 divided by 2, which is 1. So my A in here, my amplitude in here is 1/2, right? And just in case you want to compare your answer to the graph, like this distance from here to here is actually 1/2, if you like can see it from the tick marks of the function. Okay, and now we're done with A, right? So now we have to find omega. What is omega? It equals to 2 pi divided by T. What is T in this case? Okay, first of all, let me take out like these mark in here. Okay, so say this one is the first point of the cycle, right? And it goes on and it stops in here, right? So this one, it marks out like the complete cycle of it, right? And if you notice, the distance from here to here is from 0 all the way to 4 pi over 3, right? So I know that the period in here, it is 4 pi over 3. Okay, and if you guys remember, 2 pi is 2 pi over 1. And then since we dividing two fractions in here, you have to follow the rule of keep, flip, multiply. Keep, flip, multiply. What do I mean by that? The first fraction, I'm gonna keep it. Then I'm gonna flip the second fraction to get 3 divided by 4 pi, and then I multiply them. Okay, And here, before I multiply, I'm going to cancel some of them. So the 4 and the 2 in here, I'm going to get a 2 in here and a 1 in here because I like cancel the 2 and the 4, okay? So top with top, I'm going to get 3. Bottom with bottom, I'm going to get a 2 in there. So then my omega, my w in here is actually 3/2. Okay? So now let's talk about the final answer for this one. So what does this function look like in here? Well, we know the form of it, right? Like we know it's going to have this form in here or this form in here. Okay? And because, like, if just imagine, like, if you move this function up a little bit, it's going to pass through the origin, right? So the midline actually is going through the origin. If you were to lift the blue curve, like, up on the, you know, like, x-axis, it's going to pass through the origin. That's why I'm going to go with sine for this case, okay? And if you don't want to, you can use cosine also, but then you have to, like, change, like, everything, and that will be, like, you know, like, harder. Okay, I'm gonna give you guys, like, an example when you know that it's gonna be like cosine function, okay? But for this case, at least, let me just keep it with sine. So my final answer is gonna look like this. So I go y equals to a, and my a in here is 1/2. And because it's passing through the origin, if you lift it up, it's gonna be sine here, and omega in here, or w in here, is 3/2. So I'm gonna write 3/2 and then x, and then this is the final answer. Okay, so then this is for your part. You're gonna have this graph in here, and just a heads up because it's like literally passing through the origin, right? So this one is also a sine graph, so you have to base up on this formula right here. Okay, and like I promised from before, let's say let me give you like a function. Let me put it in pink. So this is my x and y coordinate, right? And let me give you like a cosine function so you guys know that it's like a cosine function, right? So here, let me think. Oh, here. I have a good one. I have a really good one. Okay, let me put it up here a little bit. Okay, so just imagine if I'm gonna give you something like, okay, that's that one. Okay, I know from the fact that this is gonna be like what is it, the cosine function. Why is it? First of all, let me draw the midline so you guys like can agree with me that the midline here, it doesn't pass through the origin. Even if you like shift this point down to the origin, it doesn't pass through the origin, right? While for this one in here, the midline is right here. So as you can see, like this in here is on the midline, right? So if you shift it up to the origin, it's gonna be the origin. But this in here, since it's not on the midline from the beginning, so this is actually the cosine function, and you have to stick with this form right here, okay? So it's really kind of like, you know, like hard to explain, but like just, you know, like by practice, you will see it right away. If it's on the midline, like the shifting position of the origin, if it's were to be on the midline, then it is a sine function. If it were not to be on the midline, then it is the cosine function. Okay? And if it confused you on this one, please talk to me. Okay? Please email me so that I have another chance to explain this one better. Okay? And this one, I give you the unit circle. I personally, like I told you guys, I didn't grow up with a unit circle. I didn't grow up with a unit circle, so I'm not gonna talk a lot about a unit circle. I just give you as a you know, like a tool in here if you guys familiar with it, and if you guys want to use it. But I can assure you guys that if you know the idea of reference angle, which we learned from like, I don't know, like 7.4, then you are safe without a unit circle. You don't need this unit circle at all, okay? But I'm giving it to you, you know, just as a tool if you guys want to use it, okay? I actually have a really cool trick to remember the unit circle again, but I'm not going to waste your time trying to explain about a unit circle in here. But if you want to know it, if you want to hear about it, let me know. I'll share with you guys, okay? So thank you for your listening. Take care and have a great day. Bye-bye.